My name is Elspeth Peterson. I am an intern this summer at the University of Iowa. This summer I've been working in Dr. Ratner's lab in the NSF EPSCoR grant, working on gasification of biomass as an alternative source of energy. And today I'm just going to do an overview of what is biomass gasification and what are some benefits and drawbacks of this energy source. So first of all, what is biomass? It's anything that's recently been alive, like plant matter. Some good examples in Iowa that are useful are wood chips, any kind of wood manufacturing, paper, things like that. They're going to have leftover wood chips. What are they going to use them for? They just become a waste. Waste seed corn is any seed corn that's been treated. You can see in this picture there's some pink and blue seed corn that's been treated with antifungal, antibacterial, things like that. They can't just be thrown in a regular garbage can. They have to be buried specially, so that becomes a cost. If we send it through our gasifier, the temperatures are so high that it effectively destroys the toxins in the corn, and so then that's a really good way to dispose of it. Oat hulls. Up in Cedar Rapids we have Quaker oats. They shell a lot of oats and then they have oat hulls left over. That's another really good source of biomass here in Iowa. And then corn stover, obviously everything that's left over in the fields after the corn harvest can be collected and then sent through a gasifier, produce energy. There are some drawbacks with all three of these methods, obviously. Transportation, none of them are, as energy dense as, a trainload of coal is going to have a lot more energy in it than a trainload of corn stover. So that's something that people are working on. How to transport this stuff, how to collect it, how to make it economical to transport this stuff around, how to store it, things like that. Some other things that we can use in our gasifier here on campus are plastics, railroad ties, old tires. These are things that people just discard in dumpsters. They create methane, other harmful chemicals. When we send it through our gasifier, it's such a high temperature that it can break down these, the hazardous chemicals and things like that and make it neutral enough that we can just, dispose of these things and get the energy from them. What is gasification? Up at the top here, I have just a very simple stoichiometric calculation of, the very first one is biomass. We add some oxygen or another oxidizing agent. Some gasifiers use steam, ours does not. Things we get out of it are methane, is the first one, CH4, carbon monoxide, which can actually be burned for energy, carbon dioxide, which is a waste, H2O from the steam, water. We get char, which I'll talk about later, and then tars, which I'll also talk about later. So gasification is just the burning of biomass at high temperatures under reduced oxygen, so you're not going to get a flame. It's just going to be glowing red, burning that way. And some of the things we get off of it are heat, the combustible gases I mentioned earlier, and then char, which I'll talk about in just a sec. Here are some common gasifiers that people use. Sorry, the picture's not great. The first one is an updraft gasifier. You have the biomass entering usually at the top. You can see at the very top the green area is the drying zone. Biomass usually has to be very dry to work in gasifiers, and that's another drawback of this particular energy source. So at the gasifier that we use on campus, we use waste seed corn, which has already been dried to 11% moisture or so or less. And so you can see up the top there's a drying zone. Underneath that is the pyrolysis zone, which just is part of the process of burning things under no oxygen. And then the air comes in from the bottom and moves up to the top, and the gas escapes at the top. This gasifier produces a lot of tar, but usually the tar is a bit smaller. The hydrocarbons are smaller, so they don't condense at really high temperatures. I'll get more into that later. The second one is a downdraft gasifier. The air comes in at the top, or on this schematic you can see it's in the middle, and then the gas is pulled through the hottest region, the reduction zone at the bottom, and that helps clean the gas. It kind of combines all the hydrocarbons together so that they become very large, but it also, there are fewer of them. So it's a cleaner gas that comes out of it. And then the one on the right is a cross-draft gasifier. No one really uses those. It just happened to be in the picture that I am using. So we don't talk about that one. Some of the benefits of using biomass gasification for a source of energy is that it's a carbon net neutral or a net negative, and I'll tell you why it's negative in the future. It's net neutral because you're taking wood or corn or whatever that grows, it captures carbon from the atmosphere, and then when you cut it down and then burn it, you release that carbon again, and then you grow more corn, more energy, more carbon gets captured, you burn it. It's just net neutral. It's a low cost, a lot of these things are using waste that people don't want, so obviously it's going to be free or low cost to obtain the biomass. Scalable, these gasifiers can be made very small, very large. People can use it at a farm, or a power plant can use it to run a city. It doesn't require fossil fuels, so that's good. Everyone's looking for that. And continuous power generation, it's not going to be like wind energy. You can run it day and night. It's a renewable resource that you can use at all times. It's flexible. I talked about the different biomasses that we can use and the different setups that you can make. So, the possibilities are pretty much limitless as far as you can imagine. And then it produces a soil amendment. This is what I was talking about earlier with the char that comes out. And it can help improve soil quality. And here is biochar. The one that we use corn, and so our biochar looks a lot like corn, but it's very, very light. It doesn't, when you hold it, it doesn't make your hands black. It's not sooty. It's just like this very pure carbon that is very porous. And so you can see some examples here of hardwood, rice hulls, switchgrass, and so on that some other people have worked on. And this biochar, you can put it into the soil. It helps with absorbing water. It helps with the biome, the microbes that live in the soil. It gives them a place to live. It really is just very beneficial to soil as long as your feedstock doesn't contain a lot of sulfur. And right now the EPSCoR students at Iowa State are working on amending this into the soil and seeing what the results are going to be and how beneficial it will be to the soil, how much you can add and how little you can add, things like that. So that'll be really exciting to see what they're working on. And here are some of the drawbacks. I already mentioned the feedstock has to be low moisture. Obviously, you have to transport it, you have to store it, you have to figure out what exactly you can use. A lot of gasifiers can use multiple kinds of feedstock at the same time, like I was talking about with the plastic and the corn. Like if you're using corn and plastic, you have to figure out what size each one has to be because they burn at different rates. And the corn in our downdraft gasifier creates a really great bed of active carbon pretty much that's really, really hot. And then when you pull the plastic through, the plastic gases, it cleans them. But how much corn do you need versus how much plastic to keep the gases that are coming through clean? And then you have to figure out what sizes of the plastic you can use. You have to have everything be of uniform size when you're feeding into the gasifier so that everything burns at the same rate. Biomass storage transportation is a difficult thing that people are working on. Initial cost, you have to build a gasifier. You can build them for cheap, but for ones that work really well, you're going to have to put some capital into it. And then tar production, which I mentioned earlier, this is really a huge problem. This is probably why gasifiers aren't seen across the country everywhere, is that people are having problems figuring out how to get rid of the tar that is a byproduct of this gasification process. And here, what is tar? It's composed of hydrocarbons ranging from a few carbons to thousands of carbons. They can just be huge, huge molecules. It's a result of incomplete combustion, and they're generally larger. The hydrocarbon, the lower the temperature it will condense out, or the tar dew point is what a lot of people are focusing on now. At what temperature is this tar going to condense out into the tubes that you have onto the equipment you have downstream of this gasifier? If you want to store the gas, where's the tar going to go? What are you going to do with it? Things like that. So here I just have a few figures. The first one, the downdraft gasifier. People have classified the tars: primary, secondary, and tertiary tars. The primary tars are the lighter ones. They don't condense out at the high temperatures, but generally when you have those, you're going to have a lot of them. So the first one, the downdraft gasifier, like I said, it's going to have large tar. They're going to be hydrocarbons, aromatics. Oh shoot, I did this. The graph is wrong. The first one should be 1 gram per, so it's going to have not very much tar, 1 gram per cubic meter, or 0.1% of mass of the fuel. The second one, the updraft, you're going to have a lot more carbon, or a lot more tar, but it's going to be smaller, 10 to 20% of the mass of your fuel. And then it's going to be 100 grams per cubic meter. And then the fluidized bed, which is one that I haven't really discussed very much, this is one where your biomass is going to be kind of bubbling, and air is going to come up from the bottom of the gasifier. It's going to kind of cause the biomass to bubble around as it's gasified. This one is kind of in between. It has 1 to 5% mass of the fuel is going to turn into tar. It's going to be a mix of secondary and tertiary tars, so some big tars again. And here you can see a great illustration of what happens downstream of gasifiers if you don't clean the tar out. This is just an image I found online of I don't know exactly what it is, but you can see there's a huge buildup of tar that whatever piece of machinery is clogged. It's going to create some downtime. People are going to have to take apart the machinery, clean it, put it back together. So people are really, really trying to figure out how to either make a gasifier that does not produce tar, or how to effectively clean the tar once it comes out of the gasifier. And so there aren't really good options yet. Some of the options are cold scrubbing, which is using water or oil, but for that you have to lower the temperature of the gas. And if you want to use it later on in combustion or something like that, you don't want to have cold gas, you want to have hot gas. Another option are catalysts, like nickel. Some people are using dolomite and olivine in the gasifier. These things help with the gas, but they can become dirty, they can become poisoned. Some of them are really expensive, so those aren't great options either. Cyclones, people are sending the gas through cyclonic filters, trying to get the particulates out, trying to get the tars out before they send them downstream. Again, these don't work great. A lot of work can be done on this. The gasifier that we are using on campus it's a downdraft gasifier, like I said. It has the large tars in it, but the gas goes directly into a boiler where it's combusted, so we don't really have problems with tar. And people who are combusting their gas right outside of the gasifier, that's not a problem. But if you want to run a gas turbine, a fuel cell, an internal combustion engine, these applications are all going to require very clean gas. And so finding ways to clean this gas is something that's going to be an important part of using gasification as an energy source in the future. So some things that people need to work on, I've mentioned throughout the webinar. We need to find effective catalysts. We need to find efficient ways to scrub the gas, better filters, just general gas cleaning methods. We also need to develop biomass processing, storage, and delivery, and enhance the gasification methods to create clean tar. Pretty much we're all working toward how to get clean tar or clean gases so that we can run different energy producing machines off of this gas. So thank you very much.